In this video, we are going to start with a rectangular coordinate and we're going to find the polar coordinates. And so the important things that you want to know are the things that are in this green box here. That x is the same thing as r cosine of theta, y is the same thing as r sine of theta, r squared from the Pythagorean theorem is the same thing as x squared plus y squared, and theta is the same thing as the inverse tangent of y over x. And you might want to have a calculator on hand. All of this stuff here is derived using a right triangle. Okay, so we have this example here. Find the polar coordinates for the point that has a rectangular coordinate of 2, -2. So 2, -2 is going to fall right here, 2, -2. And if I were to draw a right triangle coming out of the origin, oop, that was an ugly triangle. If I were to draw a right triangle coming out of the origin, that is what I would draw. And of course, this would be the angle theta. So 2, -2 tells us that this side is -2 and this side is 2. And using that information, could I figure out the hypotenuse, which would be r, and theta? So remember, polar coordinates are always in the form of r and then theta. So let's figure out what our r is. Well, 2 squared plus -2 squared. That's going to be 4 plus 4, which is going to be 8. Well, that gives us r squared, which means that r would be the square root, and we only care about the principal square root right now. So that's the positive side of it. So r equals the square root of 8. And of course, we could break that down into square root of 4 times the square root of 2, and so r is 2 root 2. R is 2 root 2. And so in our ordered pair, we would say r is 2 root 2. Now we need to figure out theta. Well, if I know my opposite side and my adjacent side, then I can say that tangent of theta is my opposite side divided by my adjacent side. And so tangent of theta is going to be equivalent to -1. So to get theta, I would do the inverse tangent of -1, and I know that tangent is -1 at -45 degrees, or -pi/2. And if you don't know that, you could take your graphing calculator and you could say, okay, what is the inverse tangent at -1? This is in radians, and that is pi/2. No, pi/4. Sorry. Did I say pi/2 earlier? Pi/4. So those are equivalent. And so we figured out that theta is -pi/4. Oops. So this and this is equivalent. Those are equivalent statements. Now I'd like to give you time to solve one by yourself. So let's change this to 3, 4. So I would like you to find the polar coordinates for the point 3, 4. Pause the video here, and when you're done, go ahead and hit play. Okay, so the first thing that I like to do is graph this and see, where does this point fall? 1, 2, 3. 1, 2, 3, 4. And so this point is right here. The next thing that I like to do is draw a right triangle to help me find my theta and my r. When we write this in polar form, we're going to have r and then theta. And r squared equals 3 squared plus 4 squared. So r squared equals 9 plus 16, which is 25. So r is 5. So I'm going to replace the r with a 5. Now I need to find theta. Well, my vertical component is 4, my horizontal component is 3, and so tangent of theta is opposite over adjacent. So to get theta alone, I would have to do the inverse tangent, and the inverse tangent would be inverse tangent of 4 over 3. I need to grab my graphing calculator. And I get 0.92729, blah, 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 blah. Let's just round that to 0.93 radians. So theta equals 0.93 radians. Now, that doesn't make a whole lot of sense to me. That's really hard for me to understand. Where is 0.93 radians? I know that 1 degree is about 57-ish because we solved that before. But let's see, if I were to put this in degrees, where would that be? So I'll go back to the graphing calculator, I'll switch it to degrees, and about 53 degrees. So now let's look at this point that we drew out, or maybe we will draw our own, 3, 4. Oops. 3, 4. And does that look like it's about 53 degrees? It does, and it is on the 5th line. So we know that we did that correctly.